They told us not to look. That between October 28th and 29, 2025, the interstellar object known as 3I Atlas would slip behind the sun, hidden, invisible, unobservable. But what if that wasn't true? What if the object wasn't behind the sun at all, but right there, next to it, visible, and changing in ways that physics can't explain? Stay until the end, because what we're about to uncover might completely rewrite what we think we know about this so-called comet. Let's begin with what we were told. According to NASA's JPL small body database and public tracking tools, 3I Atlas would reach its perihelion, its closest approach to the sun, on October 29, 2025, 11:36 UTC, at about 1.356 astronomical units from the sun. Astronomers and enthusiasts alike repeated the same phrase. You won't be able to see it. It'll be behind the sun. A simple, believable explanation. After all, when something passes close to the sun in our sky, glare and geometry make it practically invisible to ground-based telescopes. But as the Medium report by EarthExists suggests, that statement might have been conveniently wrong. On October 25, 2025, at 1:25 p.m. local time, the EarthExists observation team captured images of 3I Atlas, and what they found shouldn't have been possible. In a wide-field image, the sun appears clearly on the left side of the frame, and just a few degrees away, a faint object, 3I Atlas, not hidden, not behind anything, but right there, visible near the sun in Virgo. Their measurements were precise: right ascension 13H 38M 44.9s, declination 07 dig 40 dans 32.5, distance 2.34 AU, and an apparent magnitude of 15.0. That's faint, yes, but well within reach of professional and semi-professional telescopes. The article even provides screenshots of the coordinates, cross-checked with the JPL Horizons model. And here's the twist. According to NASA's own orbital data, 3I Atlas should have been positioned far closer to the sun's glare at that moment, practically invisible from Earth. But the telescope image shows it elsewhere. Visible, moving. So what's going on here? Between October 21 and 23, the same observers compared their measured positions with official predictions. The results didn't match. On October 21st, the observed right ascension was 13H 47M 54s versus a predicted 13H 46 and 57s. That's a 15 arc-minute difference, far larger than the usual error for a tracked comet. By October 23rd, the offset persisted, and the brightness had dropped slightly below expected values, by about 26%. Then, in the following 2 days, things got even stranger. The object's right ascension changed by nearly 4 minutes, its declination shifted northward by 17 arc-minutes, and its apparent distance decreased by 0.02 AU. Yet its brightness increased, more than solar heating alone could explain. If you run the math, and the author of the article does, the lateral velocity appears to reach about 3.95 kilometers per second, a change inconsistent with pure gravitational motion. It's as if something was altering its course, or propelling it. Now, before you jump to conclusions, these are observational data, not absolute proof. But they raise the kind of questions that official agencies tend to avoid. Why does any of this matter? Because when the world believes something is behind the sun, no one looks. It becomes the perfect blind spot. EarthExists argues that declaring 3I Atlas unobservable may have discouraged independent verification, effectively ensuring that only a handful of official observatories could track it during perihelion. If that's true, then any anomaly, whether in brightness, color, or motion, could easily go unnoticed or unreported. And consider this. This isn't just any comet. 3I Atlas is only the third confirmed interstellar object ever detected after Oumuamua and 2I Borisov. Each of those defied expectations, in shape, acceleration, and reflectivity. And now this third visitor appears to be doing the same. Coincidence or pattern? We've been here before. When Oumuamua passed through our solar system in 2017, astronomers first called it a rock, then an elongated fragment, then something that accelerated slightly without visible outgassing. Harvard astrophysicist Aviloeb later suggested it might even be a technological relic, perhaps a thin, light sail-like object drifting through interstellar space. Now, with 3I Atlas, we see echoes of that same puzzle. Unexpected brightness, unexplained acceleration, and an official story that shifts conveniently out of public view. So, what are we really looking at? In its final paragraphs, the Medium report warns, the next weeks may reveal whether 3I Atlas follows its predicted arc, or whether its light curve tells another story. That line was written before the object's closest approach, before we knew whether it would fade, fragment, or ignite. But here's the question I'll leave you with. If independent telescopes already showed 3I Atlas was not behind the sun, then where exactly is it now? And more importantly, what is it doing? Sometimes, what we're told to ignore is exactly where we should be looking. Subscribe for updates on 3I Atlas, because this story isn't over. They told us not to look. That between October 28th and 29, 2025, the interstellar object known as 3I Atlas would slip behind the sun, hidden, invisible, unobservable. But what if that wasn't true? What if the object wasn't behind the sun at all, but right there, next to it, visible, and changing in ways that physics can't explain?